All right, hey everybody. So, wanting to keep up with the online videos, and this is what we did on Thursday. We're just kind of wrapping up other ways to put together samples for observational studies for things like surveys and whatnot. So, picking up where we left off, we kind of had started out with the bad kind of sampling, the convenience and the voluntary response, and those things are just not something you should use as a professional researcher, but people use them, so there they are. And we saw sources of bias and the things that can happen that actually make them sort of an invalid choice. So we went to probability sampling, and remember that is just a group of sampling techniques where you use random selection and everybody in your population has the same chance of being picked. And we start out with a simple random sample, and very defensible. Don't forget that simple random sample had a special feature to it where it was all samples of size n have the same chance of being picked. Now that seems like I keep harping on that, but when we go to the next type, you're going to see that it's not a simple random sample because it won't follow that particular feature. So the next thing on the list is stratified random sampling. And I know it has the same 3 letters as SRS, but we never use SRS for this. We'll just call this stratified. And this particular one is just under that same umbrella of probability sampling. It is more accurate than a simple random sample. It is. Trust me, we'll talk about why. So picture this. So I'm studying people in Katy, and I'm interested in incomes, and I suddenly think about the population. I think, you know what? There is a very small subset of this population. You know, if I'm looking at ethnicity, for example, it's a certain ethnicity that I really want in my sample, but in the population it's only 2%. This is a group that has a lot of businesses, has a lot of money, lives in nice homes and nice neighborhoods, and I just don't think that my sample would be representative without them, right? So if I do a simple random sample, every set of n individuals chosen have the same chance of being picked. I could miss that small little subgroup, right? So I'm just going to look at ethnicity as a sort of categorical variable, and I'm going to break it down into its categories, which in this case we're going to call strata. And I'm just going to see what's out there, you know, what kind of a racial ethnic makeup I have out in Katy, and I'm just going to set up a sample with similar makeup at similar proportions. All right, so I'm going to figure out what I've got for each ethnicity, and I'm going to do a separate simple random sample within each and combine them all into a full sample. Again, we call those categories strata. And strata comes from the same word that you get when you stick a shovel in the ground and you poke it in and you pull it out with a bunch of sod and a bunch of dirt. And then if you go back and look at the hole, you can see the soil layers, right? Those are called strata too. So it's a kind of a layering process, right? And if you think back to what we did yesterday, I said, you know, you could get just regular old sampling variation at work to where if I want to grab a sample that's half men, half women, that with simple random sampling, I could get 70% men and 30% women. And actually, if you do stratified random sampling, I can avoid having that happen because I can just take my sample size, divide it in half, and fill it 50-50 with men and women with 2 separate simple random samples. That's stratifying. So you can actually see how it can be more accurate and better reflect the population than to just pick people at random, right? So in doing so, you're going to reduce sampling variability, and variability is just another word for error. So if you reduce sampling error by doing stratifying, then yeah, that's good. That's a good thing. It's going to take a little more work though. So if I've got all the kids at Cinco and I need a sample of them, you got to remember that freshmen, sophomores, juniors, and seniors occur at roughly, 25% amounts or proportions. So that would make them proportionate, similar fractions. So all I would have to do would be to say, all right, I want a sample of size 100 and stick 25 freshmen in, 25 sophomores, 25 juniors, 25 seniors. That's 4 different strata. And so I do 4 simple random samples of size 25, 1 each for the categories. Now if I turn it around and do it by ethnicity, I'm pretty sure the ethnicity for these 4 groups is not equal. So that would be disproportionate or different fractions. And truly, I am not interested in if you remember the proportionate or the disproportionate. All I want you to remember is that it would be your job to see what proportions you've got your groups in and make your sample turn out that way. All right, so here's another kind of random sampling, and naturally it would have the same 3 letters again, but we'll never call it a SRS. This is systematic. And again, it falls under that umbrella. I don't know if it's so much more precise than a simple random sample, but let's just say it might be marginally. This is actually kind of important. You have to assume that the units in your population are randomly ordered, right? That there's no patterns in it or any kind of predictable behavior. And when we get to the downside of this sampling method, you'll see why. All right? All right, here's what you do. You select a random starting point and select every nth individual. So from that random starting point, before you've picked it, everyone has the same chance to be picked. Afterwards, you're kind of locked in. So if you're doing every 10th one, or let's say every 5th one, then you might start at 3, then you get your 8th one, your 13th, your 18th, your 23rd, and so on. All right? So you only have one random value to deal with. Unlike yesterday when we picked the 7 individuals out of the 21 from my original stats class, it seemed to take quite a while because we got 3 or 4 right away. And then there was this big long section of one of the lines in the random digit table where it was beyond the numbers we'd assigned, and it just seemed like we'd never pick all 7. Here, you just go with a random starting point and you just start rolling through when you decide what the nth interval is, and we'll get a little formula to help you figure that out. All right, so I'm going to put all of this up here. This is an example of having a sampling frame. Remember, that is the group you're choosing your sample from. Let's say of 200, and you want n, your sample size, to be 40. Okay, easy peasy. You just make a ratio of your sampling frame 200 over your sample size and reduce it to some whole number, or maybe it'll be a whole number with a decimal, whatever it comes into, and that will give you your systematic interval. Now bear in mind, if you have a ratio that comes out to 5.2 or 5.4, 5.6, 5.8, anything before 6, you're going to want to roll it back to 5. If you round up in an occasion where you might think to do it and go to 6, then you're going to end up never picking your 40th person because you'll run out of numbers. So always kind of roll it back to the nearest whole number unless it is a whole number. All right, so then you would randomly pick among your first 5 one of the people to start on, and then it'll be 5 after that, every 5th one. All right, so you will end up with a sample of 40, and you won't run out of numbers, and you shouldn't really have anything left over. Maybe a few, but not for another cycle of this. And this last thing just says if the interval here comes to any kind of a decimal, bump the value down to the whole number below. So you're kind of moving back to the lowest, the next lowest whole number. All right, so the advantage of this is it's pretty quick and easy. You only have to randomly select where to start, and then boom, you're off, okay? Now, you do have a disadvantage, and I need for you to kind of picture this in your head. So let's just say you either run or own a company where you make medallions. And so down this conveyor belt comes little metal blanks. And when they hit a certain point, they stop, and down comes a press, and it pushes into an impression on it, right? And then it rolls off, and then another comes, and you get a second impression, and another comes, you get a third, and then you've got a glitchy in your machine. Actually, you've had it there, and the fourth one, it just hits it off center, so it's defective, all right? And then it just kind of shutters and then goes back to normal for the next three, and then the fourth one after that has the same thing happen. Well, that's a kind of a cyclical behavior, all right? So if there is an order to your population, then what can happen if you use a systematic random sample on this is that you could never see the defective ones, right? You could just be jumping past them, or there is a chance that they could all be defective. And then you would get kind of, from a quality control standpoint, you would just have, an outcome that wasn't real. So anytime that you have a pattern, a repetition, or something cyclical in nature, then this is a bad idea. All right, that's kind of a stretch. It probably doesn't happen much, but it's something to consider. So I think this is going to end our kind of lower magnitude sample. I mean, you can get big samples from doing this, but from a bigger scale, then this is kind of where we depart to a bigger scale. And we're going to move to a multi-stage design, right? Again, it's under the umbrella. And to do this, what you do is you just choose samples in stages, a simple random sample at each stage, with larger groupings and working down to smaller ones. Okay, this is used when populations are large and widely spread out, but I've seen it for kind of smaller sorts of situations. So remind me to hit that before I leave this type of sampling. All right, so you all may wonder, they do national polls. How do they do them? All right, well, what they end up doing is they will get a list of all 3,000 U.S. counties and parishes, and they will take a simple random sample of them. And so whatever you pick, the rest just kind of get discarded. And from those counties you picked, you go to the next lowest kind of, I don't know, in this case, these would be sort of governmental boundaries. So you might choose townships. Now, where I grew up in the Northeast, we had townships. But here, I think you would probably go to like MUD districts, municipal utility districts, because that's a natural division in the county that we live in. So maybe you would take a simple random sample of those. From those, you would take a simple random sample of the blocks within each township chosen. And from the blocks, you would do simple random samples of households within each block. So ultimately, you would end up with chosen blocks with a bunch of houses in it, like a little grouping, so that you could go there and you could hit a bunch of places at once, rather than, say, having chosen a house from Montana, and then your next house is in Nevada, and your next one's in Florida, and your next one's in Delaware. All right, so you can see that there's some good things that can happen here. So your advantage is that you don't need a national list of households. And why would you want that? Because there are houses being added and houses being dismantled for one reason or another all the time. So it's not a fixed thing. But counties and townships are fixed things. And you could probably Google them and just get a whole list of them. At the end, as I said, you have grouped. I don't like clustered because the next sampling type is clustering. But so you get households that are just kind of grouped together within a reachable area, and so it makes some of the logistics easier. All right, yeah, before we leave this, while I'm thinking about it, all right, so I have seen situations that are much, much smaller in scale than this. So let's take a warehouse, and the warehouse is full of big boxes. What do you suppose are in the big boxes? Yeah, well, maybe little boxes. And what do you suppose are in the little boxes? Like packages. So you could do some multi-stage design with that. And I have seen that kind of situation on an AP exam before. All right, so the very last thing we're going to do is cluster sampling. And it's different from multi-stage. You still kind of think of a population that's widely dispersed over kind of a large geographic region. You split that geographic region up, usually along geographic boundaries, and you call each of those boundaries, if there happen to be counties or whatever, you would call them clusters, and you would randomly select from those clusters, simple random sample. And once you have chosen the clusters that you're interested in, then you measure all the units that you're interested in measuring within the sampled clusters. So you could randomly choose the counties in a state, then survey all the inhabitants within the selected counties. I'm not really aware of any time this has ever been used, but it must be a thing because it's an AP item and it's in your textbook and all that good stuff. So we'll just have to keep it in mind. Another kind of probability sample. So we're going to move to bias. Not that we haven't been talking about it all along, but we're going to kind of nail down what some things are that would create bias, maybe a little bit beyond what we had. So this just when you get a systematic failure of a sampling method, when you try to use it to represent a population, because you will overestimate or underestimate some kind of parameter, and that's not good. It says you cannot recover from bias, and all I can tell you about that is, sure, you could start over, but if you're doing this in a professional setting, don't you have money constraints? Don't you have time constraints? So if you get to the end of a study and you realize it's garbage, that may be it. You may not be able to recover. So try to head off all of the bad stuff as you go. We have discussed undercoverage. That is a term. You remember the homeless when we're taking a sample? I like to use an example of, say you are taking a survey and you're knocking on doors at 2 in the afternoon. What could possibly happen that wouldn't be good in that case? Well, most people said, yeah, if you do that, people are going to be at work and you're going to miss them. And that's quite true. So that would be undercoverage. Those people that are away at work are not going to be represented. All right, what I want you to see is that you get some overlaps in these things, like non-response. An individual chosen for a sample cannot be contacted or refuses to answer. Well, what if that person's at work at 2 o'clock? All right. You can argue that the bias here is non-response because of missing that group of people. However, you could also claim it's undercoverage because you've systematically left that group out. So you can argue both. Just go into an explanation as to why you chose it, and it'll probably be fine. Now, sometimes they just refuse to answer. But whatever, the opinions of the people that aren't included might differ from those who have responded. So you've systematically left those opinions out, and it's just going to be a source of bias or missing the mark. Okay, response bias is anything in a survey design that influences the responses. All right, wording of the question should not be confusing or leading, and silly me, I came home without my 2 good examples, so I'll try to cobble them together, at least one of them. If the one that I read out to the group today was about disposable diapers, and they, there's a little bit of controversy about them because they go into landfills and they never go away, and they apparently take up room, and so people are kind of pushing cloth diapers again. But in any event, so the survey that the diaper people put out had the results of 84% of the people saying no, they shouldn't be banned. Well, of course that's what their sample would say. But the question was basically, should disposable diapers be banned, given that they only take up 2% of any kind of landfill space, whereas yard waste and plastic refuse and one other category of refuse that they mentioned that escapes me take up 21%. Given this, should disposable diapers be banned? Well, I mean, if you're going to make them look saintly next to other options, then of course a lot of people are going to just react to that and say, no, 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 we've got to not ban them. They don't hurt things too much, right? So they've been led into that opinion. The question, the wording of the question that's confusing, it was such a gloriously terrible question with such big words and massive amounts of confusion that I don't remember what it was. But trust me, at the end of it, you're just like, yeah, or no. But if you're interested, I can pull that out and read it to you in class, and you'll agree that that's a bad question. So don't confuse your responders and don't lead them, because that's just you creating an outcome rather than recording an outcome. All right, questions that would lead a person to not tell the truth. I brought up, the example of, do you smoke pot? You're liable to get a lot of lies from that. You could even ask something, though, that's perhaps less intrusive, but might even still provoke lies. If you just say, did you vote in the last election? Well, isn't it a civic responsibility and the hallmark of our democracy that we get to vote? And would you really want to publicly admit to not doing it? So just something as basic as that. Anything that's embarrassing, anything that is alarming, that maybe making people admit to things they'd rather not, then those things should be left out. All right? And unfortunately, this link doesn't work. So remember that no two samples will give you the same response. They could, but it's doubtful. You're just seeing sampling variability that you cannot avoid. You can lessen it. You can change to a stratified random sampling and try to lessen it, but you're still going to get some. All right. If you're going to have a margin of error, you need to state the margin of error. So look carefully as we go into election season, because there's a million polls being taken, and they should report a margin of error. And occasionally, they will have a front runner that they'll say, whoops, that's really not a front runner, it's a statistical tie, because both people fall within the margin of error. So if you add the error onto the person that's trailing, that person could suddenly be in the lead, right? So watch these things, it's interesting. All right, with a little clarifying, larger samples typically will give you more accurate results. They're more reliable. And I mean, think about it. If you only, ask 5 people something, you might just get 5 strange people who will answer in, a way you don't expect, and you just can't, generalize that back to everybody. But if you ask 100 or 1,000 people, you're likely to get, both sides in whatever measure that would match the population. Now, keep in mind that there is an upper limit to this, beyond which you just have diminishing returns. So for us, a big sample starts at 30. I mean, it may not be, you may want to go to 100 or 200 or 1,000, but yeah, statistically 30 is considered a big sample, which is kind of neat. All right, this is the final slide. Sorry if this is boring, but all of this you need to know. All right, it's going to show up in tests and quizzes, and I don't know how to make it go away except to finish the thing and move on. And even then, final exam and AP exam. So learn it. 3 kinds of studies. A pilot study. All right, this is just a little trial run that you put together to shake out flaws. So you might just say, okay, I'm going to run a pilot study and just send out 100 of these questionnaires rather than 500. And what happens? You get 4 back out of 100. Whoops, maybe mailing them was not such a good idea. Or you get 85 or 90 back and you think, oh, this is all right. But then you look at one of the questions and you're getting weird answers, right? And you think, ooh, that question is not performing correctly. So you either change it or get rid of it. So you can fix things and make your study that much more, defensible. 2 other kinds of studies, retrospective and prospective. Retrospective, just think of retro like, hey man, that's so retro, which refers to things in the past, right? Brings up things that once were. So it's a kind of an observational study. And so your outcome of interest has already occurred. So they use the example, you pick students, or you at least sample from students that have been through a fine arts program, and you study them for some variable of interest. So they've already been through the program, and you pick from them. In a prospective study, you're looking at what could be in the future. So you just kind of pick a number of students before they commit to a field of study, and then those that sign up for fine arts, you will then pursue your study with them. All right. So the one is after the fact, and the other is before the fact. Okay. So these are the last of our terms for just planning a study. We're going to start experiments tomorrow. Just go ahead and look at your calendar and see what the homework is. It's a textbook assignment, and that's all I've got for you for today. So good night, and I will see you tomorrow.